Alright, you guys completed functions in verse, and the first part of it was to complete some in-out tables. So the original equation they gave you was y equals x cubed. So Clayton, would you like to come and fill out our in-out table for y equals x cubed? And how did you get those values, Clayton?
Plug -1 in for x.
Okay, questions?
Cube them.
Your inverse function that they gave you was the cube root of x. Why are you using those numbers for your ins?
Because it said to.
Oh, it said to. Their group did it right. Alright, questions for Mason. Alright, problem 2. We got y equals x minus 8. So I need a volunteer to come and do it. Little Haley, how are you getting those values?
Which ones?
Your y values.
You take x minus 8. Whoa.
Question for Haley. And the inverse in out table. Jerica, how are you doing that without even looking at your paper?
Because it's just.
Oh, interesting. So, if we look at problem number 3 and we go along with Jerica's observation, can I just flip those? And you get 7, 3, and 9, 5, and 6, 7, and 15, 9, and 13, 11. So, how many of you tried to write an equation for that? Did anybody? Nobody in this class did? Okay. Did some of you graph it? If you paid attention to 1 and 2, though, you'd notice, oh, it just flips. So, questions? So, what generalization can we state about the domain and range? What is true about our domain and our range? What's true about the domain of the original? So our domain stayed the same on this problem? From our original to our inverse? Oh, the domain of our original becomes the range of our inverse. This is a key thing that you need to know for next time. Hint, hint, wink, wink. Clayton's on to something, kids. Alright, so our original range is the what? And that was the key thing that you were supposed to find in your table of values. So after you looked at your table of values, you looked at graphs, correct? So we need a volunteer to come draw the graph for 3, 5A, excuse me. he volunteered when nobody was volunteering.
I'm nervous.
But good question, Huffer. Okay, will you label which one is your inverse and which one is your original?
This is the original, and this is the inverse.
Turner, does your group agree with that?
I do.
Nick, what's wrong?
Well, one of mine, like,
Come draw it.
I had that, but my other one was like.
Do it in red.
Alright. One was like. Or something like that. I don't know.
Alright, so let's do it in out table for the original. What is the original? Y equals x cubed, correct? Didn't we do an in out table for this? And we got -1 is. And what was some of your other values? Okay, so if we do the inverse of this, we put -1, 8, 64, -27, correct? Because in the last examples, we realized that they can flip. And so you get -1, 2, 4, -3. So at -1, we should be at -1 for our red line. At 0, where are you? At 1, where are you? So those 3 dots are all the same. But at 8, where are you at? So that should be your inverse. Questions on that? Alright, now you guys graph the y equals x plus 8 and y equals x minus 8. So let's get those on the graph. You agree with her graphs?
Yes.
Okay, I'm going to go and extend this one